What's up, Chuckles? Here we are we're going to go over example 1 for this. So what is 9.2 about? Well, 9.2 is about us finding the regression line or the line of best fit, as you may know from algebra. Let's find that line of best fit. And then what we can do is we can take a bunch of data points. We can find the line of best fit, and then we can use that equation that we find to make predictions on other sorts of x's. Okay, we can, if someone asks us a question, we can say, oh, according to this line, this is going to happen if you want to know about that. So what we're going to do here is we're going to skip right to page 514 because that gives us some stuff here. But basically, the page before talks about the line of best fit, the regression line, and we say in stats, as one of the lines where it says the residuals, the sum of the squares of the residuals are at a minimum. So basically what that means is if you draw a line through a scatter plot, what you want is the regression line, or the line of best fit, is the line where all of the data is, and it's taking every single data point in there, the shortest distance away for all of them. Okay, because you can draw a bunch of lines through that data, but we want the one that fits the best. Now, we have the equation of a regression line right here. Obviously, you've seen this before, but now we have a y hat, which indicates the predicted y value if we give it an x value. Okay, a little bit different from algebra there with the y hat, but you're going to recognize this, mx plus b. Yeah, we know that. M's that slope and b's that y-intercept. Those are old friends of ours coming back to see how we're doing in like a senior level stats class. Okay, or, you know, if you're taking it at college, we would go over the same kind of things in college, in a college stats class. So what you can do is, it says y is that y hat is the predicted y value, the slope m and the y-intercept b are given by these equations, and you're going to see some sigmas in there. You're going to be doing some summation with some multiplication, and that's, even though it looks kind of hard to the lay person, it's not difficult per se, but it is kind of lengthy. Okay, you can use your list to do that, and so on and so forth. And it gives us, you know, you have your b is your y bar means the mean of the y values and all that. But what we're going to do is we're going to use our technology to find that. Okay, so let's take a look here. So this example uses the same stats, or the same data, I guess I should say, the same data from 9.1. So it talks about advertising expenditures and company sales data from 9.1. It tells you right here. And here's our little guy again. And if we go in, what I would want to do is put that, oh, I gotta move my face here. Okay, so I can get this, go in here, and I have pre-put those into list 1 and list 2. Okay, so what we're going to do is, what you're going to do is go in here, you're going to hit stat, calc, you're going to scroll down to linreg, you're going to hit that, make sure your X data is in the X list, your Y data is in your Y list. You're going to scroll down here, you're going to calculate, and it's going to give you, here in the calculator, it says y equals ax plus b. A is your slope and b is your y-intercept, but we know in our context that's going to be mx plus b. So it gives you your slope and your y-intercept. And you guys probably, it resets because every time I click off, I have a virtual calculator, but your calculator still probably have diagnostics on. So you're getting r squared and then your r down here from 9.1. So that's fine. So let's take a look here. Well, we're running out of time, but as you can see, oh man, my face is everywhere. Here is our line. So we would just put that together. Y hat equals 50.729x plus 104x. We got that from here as well. Whoops, that was weird. So it's right there.